So I'd like to introduce Dr. Patrick Michaels, who is a climate expert and author. He's the director of the Center for the Study of Science at the Cato Institute in Washington, D.C. He's past president of the American Association of State Climatologists, was program chair for the Committee on Applied Climatology of the American Meteorological Society, a research professor of environmental science at the University of Virginia for 30 years. So his credentials are quite strong. So are his opinions, but he calls it facts, so you can determine which they are. He's the author of 6 books on the climate and its impacts, and also authored the Climate Paper of the Year, awarded in 2004 by the Association of American Geographers. So our first speaker of the day, would you please welcome Dr. Patrick J. Michaels.
Thank you, sir. Thank you very much for that kind introduction, Ken.
Well, I'll start off with one of the reasons that we do what we do at the Cato Institute is we are interested in the way that economic incentives influence behavior. And I can tell you, when scientific issues are portrayed as the end of the world, you can be sure that they are portrayed that way, not for reality's sake, but for the sake of policy. So that you hear repeatedly that climate change will cause terrible problems for Iowa agriculture. If there's a drought, it's caused by global warming. If it rains during May and you can't plant for a couple weeks, that's caused by global warming. If it's hot, it's climate change, and the latest one. If it's cold, the polar vortex. Oh my God, Al Gore would say, scientists say, that was caused by global warming. Well, guess what? There's been a polar vortex around the Earth for as long as the Earth has been rotating and has had an atmosphere. It is nothing new. Now, the fact of the matter is that if something explains everything, it can't be tested to see if it is real. That is not science. If something explains everything, it actually explains nothing, because you cannot test it against what it should not explain. Now, let me tell you a little bit about climate change, some of the things that are real about climate change. First of all, the surface temperature of the Earth is higher than it was 100 years ago. How high? About 1 degree Celsius. Okay, was that caused by human beings putting carbon dioxide in the atmosphere? Well, if you look at the history, right now I am giving you my PowerPoint presentation in my mind. If you look at the history of surface temperature around the planet, what you will see is that it warmed about 0.5 degree between 1910 and 1940. And then it cooled down for a little while, and it warmed another 0.5 degree between about 1975-76 and 1997-1998. Well, the first warming was not caused by putting CO2 in the atmosphere, because we hadn't put any in to speak of. If the second one was caused by that, it was no larger than the first one that was not caused by that. Which leads you to a very interesting conclusion. How much of the recent warming is caused by what I refer to as pernicious economic activity? Because that's really what the Greens are after in this issue. They don't like development, and they don't like you. Face it. So, that has given rise to a major controversy in science, which is what's going on with the climate. Now, I can tell you that there are 3 schools of thought on the issue of climate change. I divide them into 3 groups, and I give them names because the names are very descriptive. They are hotheads, flatliners, and what I call lukewarmers. Hotheads think the world is going to come to an end from climate change. Needless to say, they dominate the scientific literature. Why is that? Because if I write a paper and it says that global warming is the most serious problem confronting mankind, I guarantee you that it is going to get a very light review and be published in the most prestigious journal. Why is that? Because the reviewers, like me in that case, are all receiving federal funding for climate change. And this paper implies that in fact that this is a very serious problem. And so the funding will continue. If I send a paper in that says, oh, this is an overblown issue, and it's really not as bad as people said it was, that paper will get a horrible review. Why? Because the reviewer of the paper knows that if enough of this stuff comes out, the money will stop. And you know the worst thing that can happen to a scientist? He has to go back to the coach section of the airplane. They will stay away from that at all costs. So, here we go. So the title of this talk is Climate Change in Iowa Agriculture. It may shock you. Are we on now?
Just the slides.
Okay, good enough for government work. I hope we're on. All right. So, whoa. The title of this talk is Climate Change in Iowa Agriculture. We're all going to live. Okay? If somebody comes from Washington and says, if you don't do this, my sound's on. If you don't do this, your children are all going to grow up to be midgets. Don't believe them. It really doesn't work that way. However, they will testify to that effect in front of the Congress. Why? To stay out of coach. Now, this is the temperature history that I was telling you about. There's the warming of the early 20th century. By the way, this laser pointer could use a little Viagra. There's the warming of the early 20th century, then it cools down to about 1975, and then comes back up. And I told you that the second warming starts around 1975-6 and ends in 1997-98. Yes, it is true. The surface temperature of the planet hasn't budged for 17 years now. This is an embarrassment to the climatological profession. There are 5 separate explanations for this, none of which are true, that have occurred already. So here's what I'm going to do. I'm going to divide the world into 3 groups: the hotheads, the flatliners, and the lukewarmers. Hotheads, they believe that climate change is an extremely important issue. There's a large impact, if you will, on climate from putting CO2 in the atmosphere. The large effects are almost all negative, and everything is, oh my God, Al Gore's in the room again. It's worse than we thought. Okay? Now, the Hothead School had a date in which it was founded. They dominate the scientific literature for the reasons that I told you about, because if it bleeds, it leads. There have been studies now of the scientific literature that I am doing and others, and we are finding horrible things are going on with regard to making sure that the horror stories are published and the ones that aren't horrible are buried. The guy who started the Hothead School was James E. Hansen, retired from NASA. On June 23rd, 1988, he testified during a drought, during a heat wave in Washington, D.C., on a very hot day, that there was, quote, a strong cause and effect relationship between the current climate and the human alteration of the atmosphere. His words. Now, if you want to know what's really going on with regard to what I call the politicization of science, all you need to do is read the history of that hearing. Because he was sweating like a pig, and the reporters were all hot. Why? Because because the guy who was running the hearing, then Senator Tim Wirth, along with Mr. Hansen, agreed the night before to open the windows in the hearing room in Washington, D.C., in the Congress. Well, because they love to save energy, not money, in Washington, D.C., what happens is when you open the windows, the air conditioning goes off. This was theater being presented as science. And so Jim had a computer model that showed that it was going to get warmer and warmer and warmer. There are two scenarios in the model. One for business as usual, meaning no policies around the world that really affect carbon dioxide. That was scenario A. I tend to think that one's actually the real one. B, some policies. Some people say maybe we're between scenario A and scenario B. Now I'm going to show you how well that forecast is working out. And the temperature record that I'm going to compare his forecast to is his own temperature record. Okay? So, Fox, there are chickens in the hen house. I'm giving this the Fox test. There it is. The red line, that's the top one there, is scenario A, from when he made the forecast in 1988 to December 31st, 2013. It warms about 1 degree Celsius or so, maybe 0.8 of a degree C. The orange one is scenario B. Wow, it started to, at the beginning, it really matched the climate. That's because in his computer model, he had random artificial volcanoes. Volcanoes cooled the temperature for a few years by putting junk in the stratosphere. And a random artificial volcano went off around 1989 or 1990 in his computer model. And so the temperature dropped a little bit. Wow, what a great forecast. And the blue line, that's reality. Well, ladies and gentlemen, this is like when the forecast is for 6 inches of snow. And all of a sudden it gets dialed back a little bit because it's not snowing. You know why you never date a weatherman, right? Every time he says it's going to be 6 inches, well, about 1. So, what I would say is this graph tells us much. It tells us that it's not the heat, it's the sensitivity of temperature to carbon dioxide. You know the line, it's not the heat, it's the humidity. Well, in climate change, it's not the heat, it's the sensitivity. It's how much it'll warm up for putting CO2 in the air. And the answer from this graph should be rather obvious. Not a hell of a lot. Whoa, your children are not going to grow up to be midgets after all. Now, instead of confronting reality, he got worse. And so he has made statements in recent years that the sea level could rise 20 feet by the end of the 21st century. It's going to have to get cracking because it's actually slowed down. Grand total for rise the last 100 years is 7 inches. Maybe really going to have to get moving. Why? Because all the ice is going to fall off of Greenland. Okay? And it could do it that quickly. If all the ice falls off of Greenland, sea level goes up 23 feet. And so this is the scenario that's driving the disaster. The Greenland scenario. You can read all about it. Here's from Al Gore's book, An Inconvenient Truth, or Inconvenient Text is what I call it. And it's a picture in Greenland taken in the summer of ice melting into water, forming a river which dives to the bottom of the ice cap 11,000 feet below the surface. And you see that lubricates the ice. That means it's all going to fall off of Greenland. Okay, only one little problem. Glaciers always have water underneath them. That's why they flow. And so this is supposed to be new. Al Gore writes, I think I can read it, or I think I can have it from memory. These are a picture of the dramatic changes now happening on the ice out there in Greenland. Well, fine. He chooses his words very carefully. Now happening are the operative words in that statement. So we could consult the journal Arctic, if we could, and we could look at the this is actually my paper. Look at the temperature history of coastal Greenland. The Danes left back a very nice temperature monitoring network that begins in the late 18th century. And one thing you can see is from 1920 to about 1940, it was warmer than it is now in Greenland. Yeah, I bet you didn't know that. And in fact, around 1950, expeditions went to Greenland to see what it looks like. And lo and behold, here's from the journal Arctic in the year 1951. A river in the ice disappeared down into the bottom of the ice. Okay? Earlier this year, a paper actually made it into Nature magazine where a woman by the name of Dorothy Dahl Jensen drilled to the bottom of the Greenland ice. You can tell how old it is by counting the number of striations in the ice, and you can tell what the elevation that it was laid down was at by looking at the chemical composition of the ice. From 115 to 121,000 years ago, summer temperatures in Greenland were 12 to 14 degrees warmer than they are now. Bet you didn't know that. That's an integrated warming far greater than any human activity could induce. And what did she find? She found that after 6,000 years of temperatures that warm, the top of the ice cap, instead of being 11,000 feet of ice on top underneath it, there were 10,000 feet of ice underneath it. It's robust. It's not going anywhere. So the hothead scenario just ain't gonna happen. Oh my God! But the ice is disappearing. Ice is disappearing from the Arctic Ocean. This is the satellite history of Arctic ice, the departure from normal for the given time of year. And yes, you can see it's going down. The record starts in 1979. All of you who have some age here may remember the winter of 1976, 77, 77, 78, and 78, 79. They were the three coldest consecutive winters on the record that we have. And in fact, they were part of the signature that the Arctic was exceedingly cold. That was the era of global cooling. And so the satellite began to take its measurements of the ice when the ice was expanded beyond normally where it would be. It's not surprising that it came down. And now here, beginning about 15 years ago, it begins to drop at the end of Arctic summer. It goes down, and then when the sun goes down the first day of fall at the North Pole and stays down for 6 months, what do you think it does? Melt some more? No, honest to God, when it's night, things cool off. And so the ice reforms. Well, right now, this graphic I did last week, the Arctic ice is 750,000 square kilometers below its long-term average. Now, I don't mean to put too fine a point on it, but north is kind of a referential human thing. The Earth actually has two poles. And we could take a look. The satellite goes around the poles, checks the northern ice, checks the southern ice. Here's what you didn't read about in USA Today. The southern ice, is going up. That's right. In fact, it's about 1.4 million square kilometers above its long-term average. 1.4 above, 0.7 below. Yeah, that's right. Polar ice is expanding beyond its long-term average. And by the way, about the fact that if it melts, there's going to be all these horrible things. Don't read the fine print. I'll tell you what it says in this graphic. From the journal Quaternary Science Reviews, 2010, we know that for 3,000 years after the end of the Ice Age, which in a geologist's eye, ask T. Boone Pickens, hell, he probably was around at the end of the Ice Age. Ask him. It's a blink of a geologist's eye. In 3,000 years, from 6,000 to 9,000 years ago, we know it was much warmer up there. Why? Because the North Woods, the boreal forest, extended all the way to the Arctic Ocean. Now it's tundra. And when a tree falls in the boreal forest, I don't care whether any Zen philosopher hears it, it gets buried in the peat. And the peat preserves it. And you can carbon date the trees that are buried in what is now the tundra, and you'll find they're between 6,000 and 9,000 years old. Well, the only way the forest will grow up there is if the July temperature is 13 degrees warmer than it is now. That's right. What does that mean? It says it in this paper. It means that the Arctic Ocean was ice-free at the end of summer for millennia, and the polar bear survived. And the Inuit culture radiated. So much for that apocalypse. It's always worse than we thought. Here's a paper in Nature magazine published about 1.5 years ago, which talks about heavy rains are falling, they're getting heavier, and the computer models don't have it happening that fast. Every time you read a paper like this, or you hear about it, and you'll hear about it in the New York Times, I guarantee you, my friends at the Times tell me, the reason we do that is we can't tell good news stories. They say, when you expect people are going to read a story that says airplane lands on time? I said, yeah, if it's U.S. Airways. Anyway, so if you don't have numbers in a paper, be very careful. And I'm going to tell you something. In fact, it is raining more on the heaviest day of the year across the United States on average. It's true. You know who published the paper? I did. How much is the question in science? Just like how much is the question in global warming. So I want to show you how much more it's raining on the heaviest day of the year. As Casey Stengel said, how many people here know who Casey Stengel was? Hey, you're my age. As Casey Stengel would say, you could look it up. And I did look it up. And there it is on that graph. In the last 100 years, on the day in which it rains the heaviest in the United States, it now rains 1/4 of an inch more than it did 100 years ago. That's that much. You want to pay carbon tax for that? It's very little. It's real, but it's little. That's what my scandalous young girlfriend told me. Anyway, hurricanes are getting stronger, right? You think I'm making that part up? Hurricanes are getting stronger, right? Everybody knows that. Oh, Hurricane Sandy, which wasn't even a hurricane when it made landfall. It was a decaying tropical cyclone that was turning into a standard garden variety winter cyclone, but it just happened to hit right south of New York City. It hit more New York greenies than any storm in history, and therefore it was the strongest storm in history. Well, in fact, we can measure the strength of hurricanes. We know how hard the wind blows, and we know where they are because we have satellites. And we've had satellites since about 1970. So let's take the integrated wind and number of hurricanes, and we're going to generate something called the Accumulated Cyclone Energy Index. And let's see if they're getting stronger. There it is, folks, back to 1970. Do you see any relationship with global warming? The answer is N-O. It's not there. You know what happens in climate change? You hear somebody say something. Hurricanes are getting stronger. As a statement of fact. But it's not a statement of fact. It's a hypothesis. And you can test it. Casey Stengel would look it up. He'd go to these numbers and say, are they getting stronger? No, they're not. Okay, that's enough for the hotheads. I'm not going to do any more manful flax on that dead equine. So let's take a look at the people I call the flatliners. The flatliners think there's no such thing as global warming. They think the effect of carbon dioxide is virtually nil, and nature is causing all the climate change that we see. And you wanted to see their Bible. There it is, right there. It's the temperature history for the last 17 years. It shows no warming whatsoever. In fact, this is a very peculiar piece of behavior and requires a bit of explanation. Now, we're going to do something very boring here. We're going to do actual real science, only for about 3 minutes, okay? The rest of this, of course, is simply rhetoric, That's what my greener friends think I'm doing. Here's some basic global warming science, okay? Here, the response of temperature to putting CO2 in the atmosphere is logarithmic. That means as you put equal increasing increments in, the temperature response becomes less and less and less. The implication is, by the way, that the first changes in CO2 should drive the largest warming. That's very scary, given the fact that we haven't seen any for 17 years, and we keep putting more and more warming, more and more CO2 into the atmosphere. But that is known from physics. This is nothing new. It's been known since the 19th century, the work of John Tyndall. Now, we're putting carbon dioxide in the air in a slightly exponential fashion, meaning low-level compound interest about what you get in that money market account right now. And here we go. So it is a low-order exponent. That's a number that keeps increasing, going up faster every succeeding decade. Now, you want to know what the temperature should do? Well, I'll tell you what. If you have an exponential increase in something to which there is a logarithmic response, you add up the two functions, and in pre-calculus, you will learn that it adds up to a straight line. For this, you spent $30 billion for me and my apparently few friends to tell you that a logarithm and an exponent add up to a constant warming. But the flatliners say it's not a constant warming. There's none. All right, now I am going to do something a little different here. I'm going to show you the temperature history, including the data since 1997, 1998, back to when the second warming of the 20th century started, after the dreadful winters of the late 1970s. There it is. That's the whole record, back to when that second warming starts. Looks like a straight line to me. In fact, that's the best function that fits the data. The only question is, which straight line? And the answer is the one that doesn't show very much warming. We already dispensed with that in our fifth PowerPoint image when we showed Hansen's forecast versus reality. Okay, it's not the heat, it's the sensitivity, and the sensitivity is as low as my social sensitivity. It's not much, all right? But then there are the lukewarmers. I didn't make this one up. I saw this online a few years ago, and when somebody said, Michaels, he's the head of the lukewarm school. I am lukewarm, okay? I believe that there's a modest influence of greenhouse gases on the atmosphere, that positive and negative impacts, did you hear the word? Positive impacts will occur. You know what happens if you put carbon dioxide in the air to corn or soybeans or wheat? They grow more. Duh. You know, high school, there's the simple equation of photosynthesis. In college, you got to do the Calvin cycle. You don't want to do that. But some schools, University of Chicago actually made every student do it, which is why the graduation rate in my class was 42%. I'm not making that up, actually. That's the truth. But anyway, the high school equation is CO2 plus H2O yields CH2O. Remember that? Water plus carbon dioxide equals carbohydrates. You increase the concentration of water, the amount of water in the soil, guess what? Plants grow better until they flood. That's different. You increase the concentration of carbon dioxide in the atmosphere, given adequate water, guess what? Plants grow better. And in fact, there's a demonstrable signal of increasing yields that's not due to fertilizer and genetic improvements. It's also due to the fact that there's more CO2. There's a paper I wrote in 2002 where I said, it's not going to warm up as much as we thought. There are 5 lines of evidence that suggest this, and they all say the same thing, that it's not going to warm up 3 degrees Celsius. That would be about 5 degrees Fahrenheit. Between 2000 and 2100, it's probably going to warm up less than half of that. And frankly, at that point, do you care? It warmed up 1 degree C in the last 100 years. Are you dead yet? No, your life expectancy is twice what it was 100 years ago, and your real per capita wealth is 10 times what it was Global warming didn't cause that, but it sure as hell didn't stop it. So, think about that. Now, I'm going to talk about the future. The sage once said you shouldn't talk about the future because the future's not here yet, but I'm going to. These are the climate models used by the United Nations Intergovernmental Panel on Climate Change. I'm a very active reviewer, or have been, not for the last report, but for the other ones, and actually contributed one of their reports to the United Nations Intergovernmental Panel on Climate Change, proving that all garden parties need a skunk. But anyway, I had a lot of fun. And each one of these pieces of colored spaghetti is a computer model for the 21st century. Well, what do you see? They're all straight lines after all. That's right. $30 billion of your money later, excuse me, not your money, your children's money, and your children's children's money. $30 billion of that later, we added up an exponent and a logarithm, we got a straight line. And the solid black line here is the average of all these. Can I convince you that that's a straight line? Yeah, thanks for the money. So, what do you do when you have computer models that give you different forecasts? How do you choose which one is right? I taught weather forecasting at UVA for a long time. And you know what we tell students when the computer models say different things? One of them might say it's going to snow on Sunday. One of them might say it's going to rain on Sunday. How do you differentiate? Look out the window, stupid. Which computer model is doing the best for the last 24 hours or has done the best in the last situation like this? What do you do when you have climate models that give you different rates of warming? Look out the window, okay? We have the climate window. We have the temperature history since the second warming of the 20th century started. It's a straight line. I showed you that earlier. So there's your answer. At the low end of what's projected. Fine. So that is the lukewarm synthesis. Now, this is acquiring some what I should say, increasing scientific backing despite the great resistance in the climate literature. These colored pieces of spaghetti are what the United Nations uses for warming for the 21st century, something called the equilibrium climate sensitivity, the amount of warming you get for doubling carbon dioxide. You can see the values are running around 4 degrees Celsius, and the probability, this is the probability of a certain warming, is not inconsequential for 7 degrees. This is crazy, because that ain't going to happen simply for one reason. It's not. And so beginning in 2011, we began to see a number of papers appearing in the scientific literature that have adjusted the sensitivity of temperature downward. Now you may ask, how can scientists just kind of put a number in to get an answer? Good work, Mr. Hammond. And the reason is because no one knows from first physical principles what the sensitivity of temperature to carbon dioxide is. There's no way. You can take a look and see, you can go back to the Ice Age where the CO2 was lower and say, well, how much would the temperature change? That's one way of sort of guesstimating it. But from first physical principles, there's no way. Does it surprise you when this issue first came up that the sensitivity numbers that were chosen were high? Who wants to fly in coach? So now what we're seeing, thanks in part to Mother Nature deciding not to warm for 17 years, is the sensitivities are being adjusted. And here, I went the wrong way, sorry. And here's the new stuff. The top, the black line on the top that's really warm, is the latest issue of the United Nations Intergovernmental Panel on Climate Change. It's so far behind the times, it's probably passed around absolute zero and is warming up. The lines underneath it are the recent literature. And you can see that the sensitivities are clustering around 2 degrees C instead of 4 degrees. Less than half the warming that was projected. That's right, these papers were all after 2011, except for this one, which I published in 2002. So now, the bottom line, climate change in Iowa agriculture. Okay, this can be done in a few graphs. Very, very simple. Here is the distribution of corn acreage or grain planted around the United States. You can see here, tends to cluster in the upper Midwest, There's a little bit down here in the Mississippi Valley, some irrigated corn out there in Texas, but mainly here. Here's soybeans. Same deal, except for one important difference. The very intensely planted soybean region in the Mississippi Valley. Guess what? It's a lot warmer in Tupelo than it is in Decorah. Honest to God, that's the truth. And so, if the temperature warm, let's warm it up. Here's the average July temperature in the United States. For trivia's sake, the average July temperature in Iowa is about 75 degrees Fahrenheit. That's the average of the daily high and low. Who wants to win a free drink at next year's Christmas party? You can tell the average temperature of anywhere you are without going to the books. If a person has a well, and see, there's most of the water systems here, rural systems, are well systems, you tell, I know what the average temperature here is to 1/10 of a degree. What do? You go to the kitchen, and you turn the water on cold, and you run it for 10 minutes, and you stick a thermometer in it. That's the average temperature where you are. Because down at 100 feet below the surface, the temperature doesn't change at all. It's the long-term heat. So anyway, let's warm up the temperature. Whoa, 10 degrees, from 75 to 85. That will take us from beautiful Des Moines, right there, sorry, I think better brand, you know that? From beautiful Des Moines to somewhere around here. So what will happen would be, you would switch perhaps to exclusively soybeans. Okay, I'll tell you what. Remember, it's always worse than we thought. Not only is it going to get hotter, it's going to get drier. There's going to be more drought. Despite the fact that the correlation coefficient between global average temperature and the area of drought in the United States is 0. There is no correlation whatsoever between global temperature and drought in the United States. But let's ignore the inconvenient fact and say that drought increases dramatically along with the warming. Well, guess what? Then you're going to switch to sorghum. The carbohydrate and protein content of sorghum, as far as feeding cattle and hogs are concerned, is the same as it is for corn. Same difference. Why do I think that if we switched Iowa agriculture to corn, that all of a sudden Archer Daniels Midland will be making everything out of soybeans, or out of corn, switch from corn to sorghum. Why do I think that Archer Daniels Midland will be making everything out of sorghum? Because they will. That's what people do. That's what you do. Each one of you, as Ken said, you know why you're here? Because you adapt. Iowa will adapt. Agriculture will adapt. We now have fast genetics, known as genetic engineering. It's not a shocker to me that Burpee, the home seed company, came out with a tomato a few years ago called Heat Wave for places that have hot nights. It sets fruit. That's what's called adaptation. Now I'm just going to finish right now with all the time I get this question, so I'm going to anticipate the question. But Dr. Michaels, what if you're wrong? Shouldn't we do something about this? Okay, I'm going to do something about it. We're going to pass the Waxman-Markey Cap and Trade Bill, which passed the House of Representatives on June 26, 2009. It requires that we reduce our emissions 2% or 5% below 2005 levels by 2 years ago. Hey, that was easy. You'll find out about it in the Bakken seminar. We switched to shale. Human ingenuity makes the future belong to the efficient. Natural gas produces more power at a power plant per unit of natural gas than coal. And it's abundant. And it's inexpensive. So that was easy. But then by the time we get to 2050, which is down here, that would be 36 years from today, Waxman-Markey says you have to reduce your emissions by 83%. just to give you an idea of what that is, I'll show you the per capita emissions that were allowed under the Waxman-Markey 2009 Cap and Trade Bill. You want to see it? Okay? The graph is time on the right. The vertical axis is per capita emissions. And in 2050, the average American is allowed the carbon dioxide emissions of the average American in 1867. Think that's going to happen? No. And something else happened when Waxman-Markey was passed. Any of you know what the Rasmussen Presidential Approval Index is? Every morning, Scott Rasmussen publishes a 3-day running average of strongly approved minus strongly disapproved. So that June 29, 2009 was the first day that there were 3 days of cap and trade in the approval index. On that very day, President Obama's approval index went from positive to negative and was never positive a day after that until near the 2012 election. The next week, the generic congressional ballot switched from Democrat to Republican and stayed Republican all the way to the election, beyond the election of 2010, when 65 seats switched parties. By the way, in the House, every close race was lost by a Democrat who voted for cap and trade. Did you know that? In the Senate, every close race was won by a Democrat. What was the difference between the House and the Senate? The Senate didn't pass cap and trade. So that piece of very unpopular legislation cost the Democrats the control of the House, given redistricting probably to at least 2022. Bad legislation has consequences. If you want your doctor, you can keep your doctor, okay? Just don't vote, please. So, fine, I'm about done. So let's do the cap and trade bill. Let's have every nation of the world do the cap and trade bill, and I'm going to run the EPA's own computer model to show how much global warming will be saved. If you don't do anything using the United Nations models, you get a warming of about 1.5 degrees in 50 years. If the United States alone does it, you save about 2/100ths of a degree, and if the entire world does it, you save about 7/100ths of a degree. That's all. In fact, if U.S. emissions went to zero, we would have no effect on the surface temperature of the planet for the foreseeable future. Did you know that? That's right. Because of the emissions from China and the rest of the world, we're becoming a minor player. And I will close. How much does all of this cost to reduce emissions to the level per capita at the end of the Civil War? Whoops, I'm sorry. There it is. Here's the cost estimate. You guys are going to see pages like this pretty soon when you start to do your income tax. We don't know. You know why? Because nobody knows the technology that can reduce emissions 83%. And if you don't know what the technology is, you don't know what the cost is. Only one thing, I'll tell you, it's big. Thank you very much.
Dr. Michaels, most enjoyable, informative. Thank you very much. We'd like to do questions with each of our speakers for the day, and I'm old, I can't run a lot, but I can throw this, so we'll see how this all works out. So if you have a question about the United States, quite a bit on our climate, and then at the last you stirred in that, you know, anything on pollution and other things worldwide. Will there be any differences in your view of changes in the climate in South America, where that we have competitors, versus North America?
No. The answer is simple, and I think you're referring largely to Brazil and Argentina. Brazil's climate, being more tropical, is in fact less sensitive to changes in carbon dioxide than the United States. And the Brazilian farmers are just like you, and they're going to adapt to whatever, too. Argentina may be a slightly different story, but that has to do with the inherent political instability, and nothing that have to do with the farmers in Argentina.
I have a question here.
Yes, question concerning Greenland.
Ah, yes.
Being somewhat of a novice student or interested in this, I understand, first of all, the reason Greenland has the name Greenland was because I believe it was in the 1200s or somewhere in that time period that the
It was green.
Pardon?
It was green.
Yes, that's right. And the Vikings actually raised crops and kept livestock there. Is there any validity to that?
Of course. And it was the cooling. That was what's something called the medieval warm period. Why did that happen? You want to know the three most important words in life? They're not I love you. They're I don't know. Okay? I don't know why the medieval warm period happened, but it went away. And it chased the Vikings off of Greenland. If you think all the ice is going to fall off of Greenland, you should do what I did last summer. You should go to Greenland and fly across Greenland, and you will see as you come in from the east, of course, the ice is at sea level, and the mountains are about 10,000 feet. And 20 minutes into Greenland in a Dash 8, which is about a 200-mile-per-hour airplane, 20 minutes into Greenland, the ice is now up to the top of the mountains, 8,000 feet. It's not going anywhere fast.
The next 20 years compared to the past 20 years, do you think it's likely to be wetter, the same, or drier?
With regard to precipitation forecasts under scenarios of climate change, let me just give you the cold facts. Some of these forecasts predict changes in precipitation. And then you can say, when would we detect the change? When would the signal, if you will, overcome the year-to-year noise and precipitation? Right? The average value for that, I've calculated it and gave it as a presentation at the American Geophysical Union last summer. The average length of time where a significant change is predicted for that change to take place is 362 years from now. You've got bigger fish to fry. We don't know. I don't know. Anybody who says they do either is unaware of the real numbers or thinks you're not going to look them up. Precipitation, no. Temperature, it should ultimately resume some warming. But if it began to warm again today, at the rate that it did from 1976 through 1998, we would still have no warming trend from 1998 through about 25 years. That's a fact. So this lack of a warming period, statistically, is going to go on for a while. How you can maintain this hysteria with a quarter century of nothing is testimony to the power of the legacy dinosaur media.
Question over here.
Doc, I'm curious about your thoughts on methane, whether you think that is something that we ought to be thinking about capturing.
Oh, why not? I mean, the fuel, that's a good idea. Methane, which is released upon hydraulic fracturing, that was a dramatic overestimate in the Cornell paper. Nice thing about the internet is the internet is compensating for the shoddy review process that's going on, where if you submit the paper that it's the end of the world, it gets published, and if you don't, it doesn't. I've seen papers torn apart in 15 minutes that were published in Science magazine, torn apart to the point that they had to retract them. So the paper on methane, that really got killed. Yes, capture it. It's a potent greenhouse gas, and it also can be used to heat your house. So take advantage of it. You know, the old saying, acres of diamonds underneath your feet. They're there.
Biofuels. If we burn biofuels rather than fossil fuels, would that have any effect, positive or negative, on greenhouse gas emissions?
No, it wouldn't, because biofuels are very close to carbon dioxide neutral. You have to, you got to use fertilizer. If you're going to use switchgrass as a biofuel, you have to figure out how to break down cellulosic ethanol. You know what? I've been told we're going to be able to break down cellulosic ethanol that is just around the corner. I've been told that since I was just around the corner, okay? Which is a long time. Not as long as Boone Pickens, but a long time.